In this video we're going to have a look at algebraic division and a process called long division to make this occur. But what does it actually mean when we divide an algebraic expression by another algebraic expression? Well, let's have a look at the process with numbers. We know that when we divide 12 items, in this case we've got some purple dots, by 3, we can divide them into 4 separate groups, and we can see those 4 separate groups here in the colours. We also know that 12 is equal to the product of 4 and 3. So we'll keep this in mind when we look at the inverse operations later for algebra. So going back to our original problem, we're trying to divide this quadratic expression, x squared plus 11x minus 26, by the linear expression x minus 2. Let's first of all go in reverse to what we did before and see if we can express x squared plus 11x minus 26 as a product of some algebraic expressions. And we can do that with factorization. In this case we have a quadratic trinomial, and we're looking for numbers which add up to the coefficient of x, in this case add up to 11, and multiply to the constant, in other words multiply to negative 26. And two numbers that do that are positive 13 and negative 2. So we've expressed our quadratic expression as a product of two algebraic expressions. Now, using the inverse operations from before, we know that if 3 multiplied by 4 equals 12, we can also express that as 3 is equal to 12 divided by 4. And we'll do the same reverse operations with our algebra. So if we have our quadratic expression equal to a product of two linear terms, in this case x plus 13 and x minus 2, if we divide by x minus 2, in other words shift it to the left-hand side by doing the opposite operation, we're left with x plus 13 on the right-hand side. Now, going through and doing factorization for quadratic expressions is fine, but sometimes the quadratic expressions can't be factorized, or maybe we're looking at a cubic or higher powers, and we need to come up with some process that's unique to division, as opposed to looking at the product of terms and then doing the opposite operation. One way we can do that is with algebraic long division. In this long division process, we'll call x squared plus 11x minus 26 the dividend, and x minus 2 is the divisor. To commence the process, we have a look at the first term in both expressions, and we ask ourselves, what do we multiply x by to get x squared? And the answer to that is x. And what we do is we align that with the 11x, in other words the same term, in the dividend. We then multiply the first term of both expressions, that's x, and also multiply the x by the minus 2. We align that with the original expression in the dividend, and then we do a subtraction. So x squared minus x squared means that that disappears, and 11 minus negative 2x is 13x. We bring down the negative 26 and ask the same question as we did originally. What do we multiply x by to get 13x? And the answer to that is positive 13. So we place that above the dividend at the top, and then multiply the 13 by both parts of the expression x minus 2 to end up with 13x minus 26. We then do another subtraction and we're left with 0. So that means that our division has occurred without a remainder. So x squared plus 11x minus 26 all divided by x minus 2 gives us a result of x plus 13. So this time we've got a division problem involving a polynomial of power 4 divided by a quadratic. And we'll set this up exactly the same way. What we'll do is we'll set up a bracket and we'll put our dividend inside that. So going through each of the terms, we've got x to the 4 plus 7x cubed plus 15x squared plus 21x plus 36 all divided by x squared plus 3. And we ask the same question as before. Look at the first terms of both parts of this division problem and ask, what do we multiply x squared by to get x to the 4? And the solution, that is x squared. And we place that above the same term in the dividend so it aligns with a like term. We then multiply the x squared by both parts of our divisor to get x to the 4 plus 3x squared. And then we perform a subtraction between what we've just written and the original dividend, and we're left with 7x cubed plus 12x squared. We bring down the positive 21x from the dividend, And we ask ourselves the same question as before. What do we multiply x squared by, the first term of the divisor, to get 7x cubed? And the answer to that is 7x. We place that above the dividend, and we multiply the 7x by both parts of our original divisor to get 7x cubed, and 3 times 7x is 21x. Again, we perform a subtraction, and we're left with 12x squared, and we bring down the positive 36 for the next part of our division process. Now we ask the same question. What do we multiply x squared by to get 12x squared? And the solution for that is positive 12. So we write that above our dividend, and we get 12x squared, and when we multiply that by 3 we get 36. We do a subtraction and we're left with 0. That means we have no remainder. So the answer to our original division problem at the top of the page is that our result, our quotient, is x squared plus 7x plus 12. So in terms of what that means, we can actually rewrite our polynomial expression to the power of 4 in terms of a product, because we know the reverse operation of division is to multiply. So just writing out our polynomial expression to the power of 4, we can say that's also equal to x squared plus 3, in other words we've multiplied across what we originally divided, and multiplied that by x squared plus 7x plus 12. And if we wanted to go further, we could factorise that second part of that solution, because x squared plus 7x plus 12 factorises to x plus 4 and x plus 3. So what happens if there is a remainder in our division problems? We know from numbers if we've got 11 divided by 2 and we look at them as 11 dots, we can group them into 5 groups of 2, but there's 1 left over. In other words, a remainder of 1. And the way to express that is by saying that we've got 5½ groups. That one remainder represents a half of a group, or 1 out of 2 because we divided by 2. So let's have a look at a division problem where our dividend is x squared plus 11x minus 30, and we're dividing by x minus 2. We apply the same question. What do we multiply x by to get x squared, the first term in both parts of our division problem? And the answer to that is x. We multiply x by both parts of x minus 2, and we get x squared minus 2x. And then we perform a subtraction. The x squareds cancel, and we get 13x. We bring down the negative 30, and the same question applies. We look at the first term of both parts. What do we multiply x by to get 13x? And the answer to that is 13. So we write positive 13 above our dividend, and multiply the 13 by both parts of x minus 2 to get 13x minus 26. When we perform that subtraction, we get negative 4. So there's a remainder in this case of negative 4. So what does that actually mean? Well, it means that when you have your quadratic expression x squared plus 11x minus 30, and you divide it by x minus 2, you do get a result of x plus 13. That's your solution from the original division. But we have a remainder. So the question is, how do we express the remainder? So x plus 13 is our result, but the remainder is 4, and we write that as a fraction over x minus 2. Just like beforehand with the groups of dots, we express the result of a remainder of 1 as 1 over 2 in our solution. So we're going to check this. If we rewrite this expression on the right-hand side with common denominators, we'll multiply the term on the left by x minus 2 so that everything is over a denominator of x minus 2. Then when we multiply that expression out, we get x squared after simplifying plus 11x and then minus 26, and then of course we've got the minus 4 left over, all over x minus 2, and that simplifies to x squared plus 11x minus 30 all over x minus 2, which takes us back to our original question.